This video shows an over-reinforced concrete beam being tested in bending. The specimen is made from concrete containing regular Portland cement. The rebar is regular reinforcing steel. The loading diagram shows the beam being subject to 4-point bending. The testing rig is now starting to apply vertical loads to the specimen. We can see the beam displacing and cracks opening up on the tension side of the beam as expected. Then all of a sudden, the concrete in the top surface of the beam fails explosively. Right, let's slow down the footage. Let's look at the top surface. Remember that the top side of the beam is under compression. Because we have heavily reinforced the lower part of the beam, which allows a large amount of tension to be carried, the same large amount of compression needs to be carried by the concrete near the top. This causes the concrete to crush before the steel has a chance to yield. Now, for a structural engineer, that's a bad way for a beam to fail, because concrete crushing is brittle, it's sudden, and you don't get the gradual failure that you'd obtain in an under-reinforced beam. The graph shows an initial linear relationship between the applied load and the vertical displacement at midspan. Note that there is no plateauing in this plot because the steel doesn't yield. Instead, the rising plot simply stops, which implies a sudden failure, just as we saw in the video.